Okay, in this lesson we're going to continue working with mixed numbers and we're going to do subtraction. So let's get right into it. We do have to get a common denominator. So I have 4 4/5 and I'm subtracting 1 2/3. I have to have a common denominator. The common denominator for 5 and 3 is 15. So the first mixed number becomes 4 and some 15ths. The second one becomes 1 and some 15ths. Now 5 goes into 15 3 times, and 3 times 4 is 12. 3 goes into 15 5 times, and 5 times 2 is 10. I need to subtract the numerators of the fractions. 10 from 12 is 2 15ths. 4 minus 1 is 3. The fraction cannot be reduced, simplified, so I am finished. I get 3 2/15. Okay, let's look at the next one. All right, this time I have a slightly different issue because the top number is 29 with no fraction part, and I'm subtracting 6 1/3. When you have this situation, it is a little different than it was with addition. It didn't matter when I was adding because I could add 1/3 to 0 fraction, no fraction, fine. This time I'm subtracting 1/3 from a missing fraction. There must be something to subtract it from. So when that occurs, when you are trying to take a fraction and there is nothing there, you have to borrow from the whole number. This is now 28. The 1 that you borrowed needs to take on a fraction form. 1 as a fraction can be anything over itself. 1 could be 2/2, 5/5, 9/9. In this case, it needs to be 3/3. I chose that because of this denominator. So when there was nothing to subtract my 1/3 from, I had to borrow from the whole number. I had to take the 1 and turn it into a fraction, and the denominator told me what form it should take. In this case, 3/3. Now if I take 1 away from 3, I get 2/3, and 6 from 8 is 2, and then bring down the other 2. My answer is 22 2/3. So this was the first example I had of borrowing with fractions. All right, let's see what happens in the next problem. I do have a fraction here, so I'll just start working. I have to get a common denominator for 15 and 9. I can take 15 and 9, and 2 won't go into either one of them, but 3 will. It goes into 15 5 times, goes into 9 3 times. Divide by 3 again, bring down the 5, I get a 1. Divide by 5, get a 1, bring down a 1, I'm done. The LCD is 3 times 3 times 5, which is, oops, ran out of room. Which is 45. Okay, so I have my common denominator, and now I will go back over to my problem. I've got 43 and some 45ths, and I have 17 and some 45ths. 15 goes into 45 3 times, and 3 times 2 is 6. 9 goes into 45 5 times, and 5 times 5 is 25. Now it's time to subtract, but I can't take 25 from 6. If I did not have this at all, if there was no fraction there, then I would know to change this 43 to 42, and I would put, right here, I would put 45 over 45, because that's the denominator. Well, I'm not going to throw the 6 away, but I am going to add to it 45 over 45. This is the one that I borrowed from the whole numbers. It is 45 over 45 because that's the denominator it needs to be. So I'm going to write this one more time. I now have 42 and 6 and 45 is 51 45ths, and bring this one over, 17 and 25 45ths. So I had to borrow to get this. All right, I have my denominator of 45. I need to subtract 25 from 51. That's going to give me 26. 7, I can't take it from 2, so I do my traditional borrowing. 7 from 12 is 5. And 1 from 3 is 2. This fraction cannot be reduced in any way, so my final answer is 25 and 26 45ths. This time when I borrowed, because I could not take 25 from 6, I borrowed the 1 and it took the form of 45 over 45, but I already had 6 over 45, so I had to combine those for 51 over 45. Pretty long problem when I have to borrow sometimes. All right, let's look at this one. I have 49 and no fraction, and I'm subtracting 21 and a half. 49, no fraction, subtracting 21 and 1/2. All right, I cannot take a half away from nothing, from 0. So I will borrow, this is now 48. I have to write the number 1 I borrowed in fraction form, so it's something over itself. It will be 2 over 2, whatever that denominator is. Now when I subtract, 1 from 2 is 1, so I have a half. 1 from 8 is 7. 2 from 4 is 2. So I get 27 and a half. And I did have to borrow. You only borrow when you cannot take this fraction from whatever is sitting here. All right. When I look at this one, I need a common denominator for 15 and 9. And I believe we did this a little while ago, and the least common denominator was 45. So I'm not going to redo that part. So I have 25 and some 45ths. And I'm subtracting 11 and some 45ths. All right, 15 goes into 45 3 times, and 3 times 11 is 33. 9 goes into 45 5 times, and 5 times 7 is 35. I cannot subtract 35 when I only have 33. So it's time to borrow. The 25 is dropped down to 24. And it's just a coincidence that the 1 is going to take on the form of, and I'm holding this over the denominator, it's going to be 45 over 45. And I think that's what the denominator was the last time. All right, what do I end up with? The top, I have the whole number 24. Add 33 and 45, and you get 78 over 45. Here I have 11 and 35 over 45. Now I can subtract. 8 minus 5 is 3. 7 minus 3 is 4. I have 43 over 45. 1 from 4 is 3. 1 from 2 is 1. My answer is 13 and 43/45. If I got a fraction that I could simplify or reduce, I would do so, but that hasn't happened. So in this problem, it was another case of I got a common denominator, but I could not take this bottom fraction from the top one. I had to borrow 1. The 1 took on the form of the denominator over itself. In this case, 45 over 45. I added those up for 78 over 45, and then I subtracted. All right, looks like we have one more to practice. The common denominator for 15 and 5 is 15. So this will be 17 and some 15ths. This will simply be some 15ths because there is not a whole number part to this. No change on the 15, so no change on the top. 5 goes into 15 3 times, and 3 times 4 is 12. I cannot subtract 12 from just 1, so it's time to borrow. I have to borrow from the 17, making it 16. I have 1 that I'm going to write in fractional form. Because the common denominator is 15, I will write that borrowed 1 as 15 over 15. Now I'll rewrite this. I have the whole number 16. 1 plus 15 gives me 16 15ths. And I have 12 15ths. I have to remember that this is a subtraction problem. 12 from 16 is 4. So I have 4 15ths. There is nothing to subtract from the 16, so I have 16 and 4 15ths. Okay, we've done plenty of examples. Now it's your turn.